Good morning, friends. Here we are taking a break in our regular videos. Uh, that means now for Sunday's test, as you know that we don't have that much time to revise each and every topics during that regular school. So for that, we are going to continue. We are going to do the continuous revision of whatever we have learned. Okay? As you know, you have a test of chapter number 4 on this Saturday. And for that, we are going to discuss few things in video number 49. So, let us see video number 49, chapter number 4. Okay? Let us see. So, in this chapter, we have learned about magnetic field, right? Magnetic field produced due to what? So, there are the few short questions that we have to keep in mind. It is of 1 mark question. That means if this charge, suppose it is a charge, and this charge is suppose steady, then it produces electric field E. Means steady charge produce electric field, and if the same charge is moving, then it produces magnetic field. So if charge is stationary, it produces electric field, and if the charge is moving, it produces magnetic field. And this magnetic field is produced by moving charge was first observed by physics teacher, like us. Physics teacher, the name was Oster. What was the Oster's observation? Let us see. He was a simple physics teacher, right? In laboratory, he was going to explain what is conductor and what is non-conductor. At that time, he had taken one conductor, right? That conductor is connected with a battery and key. Right? And it was considered that during this experiment there was a magnetic needle. That magnetic needle he has placed, means that physics teacher Osters has placed, not placed, but it was by mistake near the conductor. Clear? So, on pressing key, when we press the key, we know that electric current start to flow from positive terminal to negative terminal of a battery. And suddenly, Oster has observed that the direction of magnetic field become like this. Oh, he was shocked. What happened? Then after, he has done one more thing. That means the polarity of that battery he has changed. So electric current will go from plus to minus. So the direction of electric current now it is reversed. So the direction of magnetic needle is also reversed. From this experiment, he concluded that what he concluded? When electric current passing through the conductor, and what is electric current? Electric current is nothing but flow of moving charges. When charges are moving, it produces electric current, right? So moving charges produce some magnetic field around the conductor. It was the first general and simple conclusion by that Oster's. Right? So this was the statement of Oster's experiment. State the Oster's experiment in a one line. Then what you have to write? On passing electric current through the conductor, magnetic field is produced around the conductor. Clear? And what is the direction of magnetic field? So we know that right hand thumb rule. Hold the conductor in your right hand. Trace the thumb in the direction of electric current and the finger wrapped around the conductor indicates what it indicates? Direction of magnetic field. So here electric current is in this direction, right? So magnetic field lines will produce like this. Got it? And this magnetic field is same, or you can say it is a constant throughout the conductor. Clear? So this was about simple logical things. Steady charge produce electric field, moving charge produce magnetic field, the direction of magnetic field. After Oster's experiment, it was considered that direction of magnetic field by right hand thumb rule. Electric current, and this is the direction of magnetic field. Clear? Okay. Now we have seen about magnetic field. Magnetic field. Magnetic field, it having symbol, which symbol? B. Okay, and it having unit Tesla. As it is a name of scientist, so you have to write Tesla first T small, or you can write capital T. There is one more unit which can be as a blank. That means 1 Gauss, or you can write capital G. 1 Gauss is equal to how many Tesla? So there is 10 raised to minus 4. So this is the answer. Answer in Tesla. So there is a conversion of Gauss into Tesla, and one numerical is already there in our exercise example that we have solved also. Okay, 1 Gauss is equal to 10 raised to minus 4 Tesla. Okay, so this is about magnetic field. Suppose we have already seen, suppose this is the direction of electric current I, like this. So magnetic field lines are like this. Clear? And you can say that this is electric current I, this is the direction of magnetic field B. So you can say that if the electric field is perpendicular to that direction of magnetic field, at that time maximum force act on it. So this is the force, right? And that force is perpendicular to both. Perpendicular to both means it is perpendicular to electric current as well as perpendicular to the magnetic field also. And that force is given by F is equal to I L B. What is L? L is nothing but length of a conductor, or you can say that length of a wire. Okay? It is easy. There is one more equation of force which is given by Lorentz. So again, let us see a small question. What is Lorentz equation as well as what is Lorentz force? So if it is asked Lorentz equation, so Lorentz equation is for magnetic and that magnetic force Fm is given by Q V cross B. What is Q? Again, if it is a magnetic, so Q is moving charge. Velocity, obviously the velocity of moving charge, and B, it is a magnetic field. So this equation can also be written as QVB sine theta. What is theta? Theta, it is an angle between velocity of charge and magnetic field. It's okay? So this is the Lorentz equation, as well as this is the equation of magnetic force. F is equal to QVB sin theta. Generally, in all the numericals as well as in that theory portion, we have taken theta is equal to 90. It means velocity of a moving charge is perpendicular to magnetic field B. Clear? And you know that if you will place theta here, so sin theta value 1. So you will get, finally, it is QVB. Clear? So, by this way, you can reduce the equation of QV cross B is equal to QVB. Sir, how there is a unit of magnetic field Tesla? So you can say from here means we will have the equation. Which equation? That is F is equal to QVB. Make a subject B. B is equal to F upon QV. F is nothing but Newton, Q, Coulomb, velocity, meter per second. Take second upside, so it is Newton, second, Coulomb, meter. Take Coulomb, meter upside, so you will have Newton, second, Coulomb inverse, meter inverse. Now it is easy from this equation to obtain dimension formula also. Newton force 121 minus second T1 Coulomb, A minus 1 T minus 1 meter inverse L minus 1. Put the values of that individual dimensions and then you will get the dimension formula. And this was invented by one scientist, Tesla. So it is also known as T for Tesla. Clear? So let us see few small questions. They are here for a few seconds. Okay? Then try to recall whatever we have seen in that regular videos. Okay? Have a look for a few seconds. Okay, now we are going to discuss. See, here in our question bank there is a question: state and explain Biot-Savart law for a magnetic field produced by a current carrying element. Define its unit and dimension formula. So unit is already here, right? Now we are going to discuss that question: state and explain Biot-Savart's law. Let us say. So this question, it is of 3 marks or 2 marks, depends upon the examiner. Okay, and if it is asked, you have to start from here what we are knowing from the beginning. Let us see what is the question. State Clear? So for that, what to take? We will do some fast revision. Okay, you have to take a wire. It carries electric current I. From this wire, let us take a small element. So this is the small element of a wire and its length is small. So instead of length L, we are taking dl. Right? Electric current is passing, that is IDL. So this is known as what? Current element. Right? Now, from this current element at a distance r, let us take a point P. So according to that left hand thumb rule, it is the direction of electric current, magnetic field lines are coming out and it is entering inside. Right? So this is the magnetic field which is perpendicular to the plane and going. Where going? Inside. Right? So at this point, magnetic field is given by dB is directly proportional to, as per our new textbook, it is directly proportional to IDL cross R caret upon R square. Okay. What is R caret? It is nothing but unit vector. Any vector divided by its own magnitude. Put it here. So we are getting IDL cross R upon R square plus this R cube. There is a vector product. Vector product means cross product. If there is a cross product, then you have to take the sin theta. So it is, oh sir, we want to remove this proportionality sign. No problem. Write down here constant mu0 upon 4 pi. So what is this? It is nothing but constant. And this constant value having, that is mu0 is nothing but 4 pi multiplied by 10 raised to minus 7 upon 4 pi. So it is nothing but 10 raised to minus 7 Tesla meter ampere inverse. Now come back to this formula, is equal to multiply by IDL R upon R cube. Here cross product, then let us take here sin theta. So 1R will be cancelled out. So here you will get the final equation is mu0 upon 4 pi multiplied by IDL sin theta upon R square. So it is simple 2 marks theory. State and explain Biot-Savart law. So by this way you will have the quick revision. Have a look for quick time, means for a few seconds only, let us say. Okay, now we are going to discuss one more theory which is there in our that assignment, that in question bank. Okay, this question is also was asked in 2020, and you know that very well known question is there. Write the equation of magnetic field due to a current carrying circular loop. Okay, let us see. So in this theory there are few things. Okay. Uh, we will. I am not drawing that entire figure, but let us see what is this. It is a circular loop which carries electric current I. This circular loop having radius how much? Capital R. From the center, let us take a point. Which point? Point P. It is at a distance x. Here you have to take two current element, that is I dl, and here I dl. Okay. Then magnetic field produced at a point P is like this. So it is dB and dB. So here we are getting two components. First component is dB perpendicular. dB perpendicular. And it is nothing but dB sine theta is equal to dB sine theta. Clear? Simple. You can see that dB perpendicular are equal and opposite in direction, so their effect is cancelled out. And at a point P, the magnetic field produced due to dB sine theta, or you can say that dB perpendicular, is 0, or you can say that it is cancelled out. Now, which component remain? So, only this component is remaining, that is dB cos theta. So, magnetic field produced at a point P is due to dB cos theta only. Clear? So, at point P, dB magnetic field is equal to dB cos theta. Just now we have seen what is the equation of dB. It was nothing but, that is I multiplied by dl upon r square multiplied by cos theta. Here what is remaining? After removal of that proportional sign, we have kept that constant, and the constant was mu 0 upon 4 pi. Now what is r? R is the distance from the line element to the point P. Here we have seen that we have to apply that Pythagoras. So it is hypotenuse side. So r square is equal to r square plus x square, and this is r square. So you can write in this form also. Clear? Here there is one angle, that is theta. So from this figure find out cos theta is nothing but adjacent upon hypo, that is r by r. Put here cos theta, it is nothing but capital R by r. So what we are getting? We are getting mu 0 upon 4 pi multiplied by I as it is multiplied by r as it is upon r cube. Already r is here. So what is r? R is nothing but r square plus x square raised to 1 by 2. If you want to take r cube, so it will become 3 by 2. Simple. So here something is remaining, that we will discuss afterwards. So it is dB as it is, let it be. Let us put here dl. Clear? So here you have to put r cube. Now this is the magnetic field for a small element, this much element, and if you want to take for the entire loop, then you must have to take algebraic sum, and algebraic sum, that is dB, is nothing but B is equal to mu 0 upon 4 pi multiplied by IR upon, now we are going to place that R cube upon R square plus X square raised to 3 by 2 multiplied by sum of all small element. So all small element combine to give a circular loop. So instead of this, what you have to put? You have to put that circumference of that circular loop. So we are getting final equation B is equal to mu 0 IR upon 4 pi R square plus X square raised to 3 by 2 multiplied by, what is this? It is circumference of that circular loop, that is 2 pi. Here R. What is R? It is the radius of that loop. So you can see that pi will cancel out 2. So here 2. So finally you are getting B is equal to mu 0 as it is I, as it is RR is nothing but R square upon 2 R square plus X square raised to 3 by 2. Simple. Okay. It was asked in 2020. So this time there is a very less chances. But then also we have to prepare well for maybe in the future tests, whatever we are giving. Clear? So have a look. After this, there are special cases. Okay? Let us see that special cases. Otherwise, you look first. Then we will discuss that special cases. Okay? Have a look. Let us take that special cases of that equation of magnetic field for a circular loop. So what was that first case? First case number 1 means if point P is at center. Previously I have removed that figure. Previously point P was at a distance x. Now if the point P is at the center, means what becomes 0? X value becomes 0. So if point P is at the center, then you have to put x is equal to 0 here. So you will get magnetic field for a center, right, is equal to mu 0 as it is IR square as it is upon 2 R square plus x term becomes 0 raised to 3 by 2. So here 2 will cancel out. There will be R cube. So is equal to mu 0 IR square upon 2 R cube. So R square R cube, only one R will remain. So we will have equation mu 0 I upon 2 R. So this is the equation for a center. In this case number 1. If it is asked, case number 1 and 2 you have to write. If it is asked, then it will be a question of 3 or 4 marks. Clear? Now let us see case number 2. So what is there in case number 2? So case number 2. Okay, where is point P? Point P is at far distance, means this is the circular ring. Point P is here in our regular theory, but point P is very far. Then in this condition the value of x become much more than r, and because of this reason you have to take r is equal to 0, where here in bracket term only you have to put r is equal to 0. If you will put here 0, then it will become 0. So it is not a way. Clear? So you have to put r is equal to 0. In which term? In bracket term only. Clear? Put it here. So you will have equation of B is equal to this term as it is mu 0 I r square upon 2. Value of r square is 0. So it is 0 plus x square raised to 3 by 2. So here 2 will cancel out and you will get B is equal to mu 0 I r square upon 2 x cube. So this is the equation when x is very greater than r, means the point P is very far from that circular coil carrying electric current. Okay, so here there is end of Biot-Savart law as well as its first application in detail. What is Biot-Savart law? That you know. Okay. Obtain the equation of magnetic field for a current carrying circular loop. Application number 1 and its special cases. Okay. Let us see for a few seconds. Okay guys, now after in next video we will see about Ampere circuital law, about solenoid, about toroid. Okay, and we will see few MCQs as well as short questions also. But before that, after completion of this revision video at your home, if you will have the time, you must have a time. Okay, then after you must have to check that Ampere circuital law as well as obtain the equation of magnetic field for a solenoid, for a toroid. Okay, have a good day, enjoy, best of luck.